everyone, in today's video we're going to be going over the MM914 December 2019 exam and we're going to be looking at question 2. Question 2 is in the probability section of the exam and it's worth 10 marks. Remember, the probability section of the exam is out of 20, so this question is worth half the marks in the probability section. Okay, so to begin with, we'll start by reading out the question. Deal 3 cards from a well-shuffled deck, containing 52 cards, 13 cards in each of the 4 suits, hearts, diamonds, spades and clubs. Let the random variable x be the number of red queens, that is, the queen of hearts and the queen of diamonds, and let the random variable y be the number of even cards dealt in each suit. The even cards are 2, 4, 6, 8 and 10. And we've got 3 sub-questions. Write the sample space conditions and draw the graph of the support, 4 marks. Find p of x of y, 3 marks. Calculate the probability that there will be an equal number of red queens and even cards, and give your answer to 3 decimal places, 3 marks. So to begin with, we'll go through question A. And in question A, just to remind you, write the sample space conditions and draw a graph of the support, 4 marks. So the first thing we need to do is separate our variables into x and y and determine how many x's satisfy this condition and how many y's as well. And then using this information, we will then draw the graph of the support. So the first thing we do is we reread the question, and if we're starting with x's, we're actually told in the question that there are 2 red queens in the deck, the queen of hearts and the queen of diamonds. So that means the maximum value that x can take is 2. So you can draw from the 3 cards you're dealing at most 2 red queens, because that's how many there are in the packet. You can also have 1 red queen in your deal and none. So the choices there are 0 red queens, 1 red queen, or 2 red queen. And what we do is we write a sample space in curly brackets. So that's us written the sample space conditions of x. Now we need to consider y. Now we're told for y that it's the number of even cards dealt. 2, 4, 6, 8 and 10 are all even cards. So that's 5, and there are 4 suits. So there's a possibility of 20 even cards. However, we're only dealing 3 cards from the deck. So that means that the maximum number of even cards from the deck, which we're going to deal, which is 3 cards, is 3. So the maximum number of even cards we can possibly have in our 3 card hand is 3. Equally, like the red queens, we can have 2, 1 or 0 even cards. Okay? And again, like in x, our sample space is written using curly brackets. So y is equal to 0, 1, 2, 3. Now the third sample space condition is the one that everyone forgets about, and that is the condition that x plus y must be less than or equal to 3. This is basically saying that the total number of cards drawn has to be at most is 3. So x plus y cannot be more than 3. What that means is we can't deal 2 red queens and 3 even cards, because that means we would have 5 cards, but we're only dealing 3. So that means that x plus y must be less than or equal to 3. These are our sample space conditions. Now what we do is we use these to draw the graph of the support. So the graph of the support, this is the finished version of it, and I'll explain to you how we did that. So all we do is we just take our points. If I go back, what we do is we take our points. So if we consider x is 0, then we can have x at 0, y 0, x0, y1, x0, y2, x0, y3, and we would plot these. So because we've got 0 and the x-axis, these are going to be the straight line, the vertical straight line here. So we've got the 4 points, x equals 0 here, x equals 0, y equals 0, x equals 0, y equals 1, x equals 0, y equals 2, x equals 0, y equals 3. Now we'll do the same for x equals 1. So we can have x equals 1, y equals 0, x equals 1, y equals 1, x equals 1, y equals 2, but we cannot have x equals 1, y equals 3. The reason for that is 1 plus 3 makes 4, and we're only dealing 3 cards. So we cannot have that point. So these correspond to our points here. X is 1, y is 0, x is 1, y is 1, and x is 1, y is 2. And then we continue. X is 2, y is 0, x is 2, y is 1, x is 2, y is 2, we cannot have because 2 plus 2 makes 4 and we're dealing 3 cards. And similarly, we cannot have x is 2, y is 3 because x plus 2 makes 5 and we again are dealing 3 cards. So this here corresponds to our graph of the support. X is 2, y is 0, x is 2, y is 1. And that is our graph of the support. Okay, moving on to question B. We've been asked to find P of x, y. Okay, so what we do in this one is we need to make use of a formula that was given to us in class. Now a reminder, this formula was not provided on the examination formula sheet, so it was one that you would have had to have known. So if we consider the formula, we've got the formula is x, capital X, choose lowercase x, capital Y, choose lowercase y, n total minus x minus y, n delt minus x minus y, all divided by n total, choose n delt. Now these brackets here, without the line for a fraction, these are what we would call it something to do with the binomial theorem, and these are the choose functions. So this, you would read this as x choose x. Now when you're doing this, you need to make use of the choose button on your calculator. It's a capital C button, and you might also want to make use of factorials. These can all be written in terms of factorials. Okay, so what do we do now? Well, what we need to do is we need to identify what everything is. So we want our probability xy in terms of small x and small y. So that means we don't fill anything in for small x and small y, but everything else gets a value. So capital X is equal to 2. This is the maximum number of red queens there are in the pack. This is the total number of red queens in the pack. Y is 20. That's the number of even cards in the pack. So there's even cards are 2, 4, 6, 8, and 10. That's 5 numbers, but we've got 4 suits. So 5 times 4 makes 20, and Y is equal to 20. In total, that's the total number of cards in the deck, and a standard deck of cards always has 52. In dealt, that's how many cards we're dealing in our hand. So from the question, it says we're dealing 3 cards. So n dealt is equal to 3. Then what we do is we simply slot these numbers into our formulation as shown here. So we've got 2 choose x, 20 choose y, 52 minus 2 minus 20, choose 3 minus x minus y, all divided by 52, choose 3. Now what I'm going to do is I'm just going to tidy up the third factorial choose on the numerator to get 30, and this is our P of x. Okay, so that if you knew the formula that was discussed in class, this question would have just been slotting in the appropriate numbers. Okay, and finally we have our third and final question. it says calculate the probability that there will be an equal number of red queens and even cards. Give your answer to 3 decimal places, and this warrants 3 marks. So the first thing we need to do is identify the scenarios in which there will be an equal number of red queens and an equal number of even cards. So to do that, we go back to our graph of the support, which is here. And what we're doing is we're looking for any numbers that lie on the line y equals x. So we've got 0, 0. We've got this point here, x equals 0, y equals 0. And if we continue on our line, we've got this one here, x equals 1, y equals 1. These are the only 2 choices we have. So what we need to do is we need to find p of 0, 0 plus p of 1, 1. So let's begin with that. So this slide just kind of summarises what I've said there. So from the graph of the support, we are looking for any points which lie on the line x equals y. There are 2 possibilities, when x equals 0, y equals 0, and x equals 1, y equals 1. We then put these values into p of xy and calculate p00 and p11. Now it's important to note if you were unable to do question B, you could still get some marks for question C, even if you said we're looking for the case where there's 0 red queens, 0 even cards, 1 red queen, 1 even card. That still would have given you marks in this question. Okay, so what we're going to do first of all is we're going to find P00. So all I've done here is every time I see an X or a Y, I've written the number 0. So we have 2 choose 0 times 20 choose 0 times 30 choose 3 minus 0 minus 0, all divided by 52 choose 3. Now any number choose 0 is always equal to 1. So 2 choose 0 and 20 choose 0 are both equal to 1. In the next bracket, I've just simplified that. 30, 3 minus 0 minus 0, so that's 30 choose 3. And then 52 choose 3 is equal to 22,100. Similarly, 30 choose 3 is equal to 4,060, and that gives us a total of 4,060 over 22,100. Notice that I'm not simplifying just now because I want to give my answer to 3 decimal places and I don't want to lose any accuracy in my solution. And then what we're going to do is we're going to repeat the process for P1, 1. So you can see here all I've done is every time I see a lowercase x and a lowercase y, I write a number 1. So we have 2 choose 1 times 20 choose 1 times 30 choose 3 minus 1 over 52 choose 3. Anything choose 1 is equal to the top number. So 20 choose 1 is equal to 2. Sorry, 20 choose 1 is equal to 20. 2 choose 1 is equal to 2. 3 minus 1 is equal to 1. So we have 30 choose 1, which is equal to 30. And that's all divided by 22,100. And if we tidy that up, we get 2 times 20 times 30 is equal to 1,200 divided by 22,100. So the last thing we need to do now is add these 2 things together. P00 plus P11 is equal to 4,060 over 22,100 plus 1,200 over 22,100. This is equal to 5,260 over 22,100, which to 3 decimal places is 0.238. And that is the final answer for this question. Okay, thanks for listening. Goodbye.